Good morning, student. In last period, we learned the type of force. We classified force into two types, that is contact force and non-contact force. And we discussed the type of contact force and non-contact force. Contact force are muscular force. Muscular force is a force of muscles of our body is an example of contact force because when our body contact any object, the force is act on an object. Similarly, more example of contact force, we hold any object, we move or push or pull by our body are example of muscular force, that is contact force. Non-contact force, gravitational force, magnetic force, electrostatic force, etc. are example of non-contact force. So today we learn the next topic, that is pressure. Pressure is a type of force and act per unit area on the surface. Therefore, pressure, the force acting on a unit area of a surface, is called pressure. Pressure is equal to force upon area on which it acts. It means force acting per unit area. If the area is small, the pressure is large, and if the area is large, then the pressure is small. It means that pressure and area on which the force is act on it is inversely proportional to each other, and pressure and force is directly proportional to each other. If we increase the force, the pressure is also increased, and if we decrease the force, applied force on any surface of object, then pressure is also decreased. It means that force and pressure are directly proportional to each other, and force and area on which the force is act on is inversely proportional to each other. So pressure is force upon area on which it acts. This is the formula of pressure. Pressure is nothing but force upon area. Pressure increases if area over which the force is applied decreases. Pressure is increased when the area is decreases. It means pressure and area is inversely proportional to each other. Similarly, pressure decreases. Where pressure is decreased, if the area over which the force is applied increases. If we increase the force applied on area, the pressure is decreases. So pressure decreases if the area over which the force is applied increases. Force, if we increase the force, pressure is increased. So pressure and applied force are such type of interconnected with each other. Pressure and area. Just like solid, liquid and gases also exert a pressure. So solid, liquid and gases also exert a pressure, liquid do not have a definite shape. We know that the liquid has not a definite shape. Its shape is depends on the container in which the liquid is stored. So liquid do not have definite shape, and hence the pressure exerted by them depends on the depth of the liquid column, which is given in your textbook, figure number 11.14, page number 138. The depth column means the liquid 130, page number 138. Figure number 11.4. This is the pressure exerted by water. Water is liquid at bottom of the container depends on the height of its column. If the height of column in the container is increased, then the pressure is also increases. And if the height of the column on the container of the liquid is decreased, then the pressure is also decreases. This is given on the page number 138, figure number 11.14. So liquid do not have a definite shape, and hence the pressure exerted by them depends upon the depth of the liquid column. Similarly, liquid exerts pressure not only on the base of the container but also its sides. If we fill a liquid on any container, and it means not that the pressure exerted by this liquid is only on the base of the container. It also exerts a pressure in the side wall of the container. This is given in figure number 11.15 and 11.16 on page number 139 in your textbook. So, liquid exerts pressure not only on the base of the container but also on its sides, which is given in figure number 11.15 and 11.16. Now, atmospheric pressure. The pressure exerted by the atmosphere on an object is called atmospheric pressure. It means atmosphere also exerts a pressure on an object. It is known as atmospheric pressure. Atmospheric pressure decreases with an increase in the altitude, it means height. If we go from the surface of Earth to some height, then the atmospheric pressure is decreases. Means at the surface of Earth, atmosphere exerts more pressure on an object if the object is lifted from a height for some kilometer. It means atmospheric pressure decreases with an increase in altitude, it means in height. And astronauts which goes to the space wear a special suit to maintain at normal atmospheric pressure for their bodies, and there is no atmosphere in space. So in the space there is no atmosphere. So atmospheric pressure is not there in the space. So to maintain the atmospheric pressure, outside atmospheric pressure exerted on our body, astronauts wear a special type of suit which maintain the normal atmospheric pressure to their body. Unless our body exert a pressure from inside towards the outside equal to the atmospheric pressure, therefore we not crossed or sunk in the space. So this is called atmospheric pressure. And if our head, the area of our head is suppose 15 by 15 centimeter area, and on the above our head the air column is there. This air column exert a pressure of 2250 kilojoule of atmospheric pressure. This is equal to 225 Newton of pressure is exerted on our head of approximate area of 15 centimeter by 15 centimeter on this column, which is given on the page number 141 on figure 11.19. So this is the atmospheric pressure and this is the pressure. The unit of pressure is Pascal. Pascal is a scientist. In the name of scientist, the unit of pressure is Pascal. Another unit, the unit of force is Newton, and unit of area, we know that meter square. So unit of pressure is Newton per meter square. Newton per meter square means 1 Newton per meter square means 1 Pascal. So Pascal is a unit of pressure. Thank you.